Good morning, everyone. Today, I would like to discuss the process of sizing electric resistors for fluid control units that are required to heat water or oil. As you can see from our production range, we manufacture a whole series of control units for industrial processes that are used to regulate temperature, thus generating a temperature-controlled fluid with a temperature range that can go from very low temperatures, -10, -20 degrees Celsius, up to very high temperatures, +300 degrees. Clearly, the fluids utilized are different. Glycol water will be utilized, diathermic oil will be utilized, silicone oils are utilized. In practice, liquids are utilized that enable working with this extreme range of temperatures. What do electric resistors do? They perform an important task, which is to heat these fluids when we do not have other service fluids, such as steam or other heat sources. Basically, these electric resistors are installed to heat the fluid, whether it is water or thermal oil. The function of these resistors is a very delicate function because it is true that they have to heat up with sometimes very important powers, as we also build heating plants with powers of hundreds of kilowatts, but at the same time they have to work without damaging the fluid and without exceeding certain temperatures that become critical for the fluid they are treating. To clarify, if we can utilize an electric resistance with a skin temperature, which is the temperature between the resistance and the water of a specific type, with diathermic oil, we should employ a lower skin temperature. This is because if we don't, the oil will be damaged, and it is stated that it will crack and carbonize, forming a layer of deteriorated oil on the resistance's skin. This layer reduces the thermal conductivity of the resistance, creating a sort of vicious circle. Eventually, the resistance will no longer be able to generate heat, and we may experience side effects such as burns, short circuits, or irreversible damage to the heating resistance. These resistors are sized based on a low specific load. We have tables we follow when designing to maintain the surface temperature within limits allowed by the fluid we are heating. This ensures the resistor operates safely and effectively without exceeding temperature thresholds, providing reliable performance in the heating system. In order to respect these temperatures, temperature sensors are obviously inserted inside our resistors. In practice, how are they made? There are small tubes that are placed in contact with the outer part of the heating element in order to precisely sense the skin temperature and limit its operation when these values are exceeded. This is the safety thermostat that intervenes and cuts off the resistors in order to prevent overheating of the same. As seen in the image, resistors can have varied shapes. Construction materials can differ, ranging from steel to carbon, copper, stainless steel, high alloy, depending on the fluids to be treated. Typically, we use specially built armored resistors, which have low skin temperatures and very low specific loads. What do I mean by specific load? I mean the watts per square centimeter dissipated by the resistor. With a low specific load, I need a larger surface area, hence larger resistances with higher costs. But this extends the life of the resistance and ultimately extends the life of the temperature control unit. I hope the topic has been clear and interesting. If you have any comments, feel free to leave them below the video. Thank you.